Welcome to all of you. Today we discuss on C programming for practical notebook according to CU syllabus, University of Calcutta syllabus. There are 26 C programs for this SEC paper, Skill Enhancement Course, Semester 1, Mathematics, B.Sc Honors and General both. So here course C language. So sample problems here uh, display first 15 natural numbers and so on so on. So there are 26 problems. A practical notebook is to be prepared with the internal assignments and to be submitted for the partial fulfillment of the course. So you have to prepare for these 26 C programs. Here Google Colab, we type this C program. Problem 1. Write a C program to display first 50 natural numbers. So date, name, C roll number, subject, paper, semester, class, college, session, all put here according to you. Has include stdio.h int main. So integer I printf for this I want this printf and run this problem first 50 natural numbers. Integer I printf the first natural numbers. Okay, it is correct, and we compile this, compile and run this by this command in Colab. Double percentage sign cell shell gcc is p1 underscore natural underscore number dot c for file extension, because here the problem name is p1 underscore natural underscore number dot c, and double percentage write file is the command for write file in Colab, and this is the file name, and .c for extension for C program. So this for compile and run, and double percentage cell gcc file name .c dash o output, and next line dot slash output. Then the output is this: first 10 natural numbers are these 1 2 3 4 5 6 7 8 9 10. Next problem 2. Write a C program to compute the sum of first 10 natural numbers. This is the problem. This print enter first positive integer, scanf in, so in maybe 10 or 20. So here this, and run this program. Now enter a positive integer, so put here 10, enter, and you get output sum equals to 55. Problem 3. Write a C program to pin numbers from to read 10 numbers from keyboard and find their average. So here this problem has include stdio.h, integer I in sum equals to 0, average is the floating variable, and this for loop I equal to 1, I less than equal to 10, printf number, input this number and 10 numbers, and sum equals to sum plus n. That means sum equals to sum plus n. This is the comment. The sum plus equals to assignment operator plus equal to sum plus n. This is the comment. Average is the floating variable sum divided by 10. So printf the average of the sum. So run and compile this. So enter the first number. There's input 10 numbers, any 10 numbers. This put here 10, 20, 30, 40, 50, sorry, 50, 60, 70, 80, 90, 100. So sum of these 10 numbers is 550 and average is this 55. Problem 4. Write a C program to find the sum of first 15 even natural numbers. So for even natural number, this I equal to 1, I less than equal to n, I plus plus, printf this 2 star I. So 2 star I multiplied by 2, so these numbers are even natural numbers. Sum equals to sum plus 2 star I. So sum of the first even natural numbers is this. 15 natural numbers, so put n equal to 15. Run this program, input 15 equal to 15, and the first 15 even natural numbers are these 2, 4, 6, 8 and 30, and sum of first 15 even natural numbers 240. Problem 5. Write a C program to find factorial of a number using recursion. So first we uh, define a function, this long integer function, this multiply numbers integer n. This is the function. So this function you can write this function in return this, cut here this, and you can write in the list here. So long integer function is a function multiply numbers for recursion. If n greater than equal to 1, return n star multiply numbers n minus 1. So else return 1 and enter the positive integer n, and this n is percentage d, integer type, n is integer type, factorial is multiply numbers, call this recursion function and return this. Enter a positive integer, suppose 25. So factorial of 25 is this. Next, problem 6. Write a C program to make a pyramid pattern with numbers increased by 1. Here I, J, S, P, C, rows and K, T are integer variable. Input number of rows, scanf rows, and SPC rows plus 4 minus 1. This I runs from 1 up to rows, and for K, SPC, K greater than equal to 1, K minus minus. Print this space. For J equal to 1, printf is percentage D T plus plus. T equals to 1, so T equals to T plus 1 here. Printf, new line, \n, SPC minus minus means SPC variable, space variable minus 1. Variables, space variables, space functions, this row space, SPC means rows plus 4 minus 1. So here number pyramid pattern row. So input here input number of rows 7. So we get this pyramid pattern for number of rows 7, 1, 2, 3, 4, 5, 6, 7 rows, and we get a pyramid pattern of this. Problem 7. From the terminal, read three values, namely length, width, height. Print a message whether the box is cube or a rectangle or semi-rectangle. But this semi-rectangle is maybe wrong. So here float length, width, height. Enter the dimension of the box, length, scan length float variable, width, scan width, and height, scan height. If length equals width or width equals height, print the box is cube. Else, print the box is rectangle cuboid. So run this problem. Enter length. Here length is a floating variable, so you can put float type number. Suppose 5.2 unit, width is 2.6, and height is 7.9 unit. So this box is a rectangle cuboid. Next, problem 8. Write a C program to find arithmetic mean, geometric mean, harmonic mean of a given set of numbers. Here include stdio.h and also include math.h, integer main, integer variable I, op, size, float sum, initial value 0, sum2 initial value 0, product initial value 0, am, hm, gm, and numbers, dimension one dimensional array numbers with 100. Here how many numbers to accept? Scanf size, say maybe 10 numbers or 20 numbers. This enter the numbers, first number, second number, up to 10th number, and do printf type 1 for arithmetic mean, type 2 for harmonic mean, type 3 for geometric mean, type 4 to terminate the program. Here we use switch option. Here the which operation do you want to perform? Scan OP operation. So either you can put 1, 2, 3, 4 according to choice, arithmetic mean or harmonic mean or geometric mean or terminate end of the program. So case 1, this sum equals to sum plus numbers I. Numbers I means the dimension up to maybe 1 to 100 numbers. So A equal to sum by size. Size is the size of the number. So 100 numbers or 200 numbers. But here dimension is 100, so it must be including with 100, 100. Cannot exceed 100. You may increase the dimension 1000, and you may increase this 1000, 1000. So this and case 2 colon for sum 2 another variable is 1 by numbers I, 1 by this. So each equal to size by sum 2. And case 3 product equal to 1 and product equal to product into numbers I. So while operators not equal to 4, not equal to 4, that is operator is not equal to 4, then the loop is executed again. So it is the do while loop. It is the do while loop, and switch option including here. So this compile this and run this problem. So here, because here we include here math.h header file, so you must write here dash lm. In this dash lm for link math header file, this dash lm, and accept how many numbers. Suppose we are given 5 numbers. So first number is suppose first number is his number is fruit type or integer type. Here numbers are fruit type. So we can put 5.6. Second number is 7.8. Suppose 9.1. This 2.3. This fruit type number. This 3.8. Type 1 for arithmetic mean, type 2 for harmonic mean, type 3 for geometric mean. So we put here 2 for harmonic mean. So harmonic mean is this. Next, put here 1 for arithmetic mean. This is the arithmetic mean is 5.72. So put 3 here for geometric mean. So geometric mean is this 5.10. And last, put 4 to terminate the program. Okay. Next problem 9. Write a C program to print multiplication table. Multiplication table. So here integer I mean void integer in printf, enter the integer, scan in printf multiplication table, and for loop integer I equals to initial value 1, I less than equal to 10, plus I, printf percentage d star percentage d equals to percentage d. So for percentage d in, second percentage d for I, third percentage d is in star I value. So first we compile this problem, and next we run this problem. Enter integer, suppose 17. So this is the multiplication table for 17. 17 into 1, 17, 17 into 2, 34, and so on. 17 to 10 equal to 170. Next, problem 10. Write a C program to generate a data file containing the list of customers and their contact numbers. Uh, this problem may be out of syllabus because here we use this pointer concept and so many other concept also. So here include header file stdio.h, include string.h. So this is the string file, so string.h header file we include here. Struct customers character customer name 50 one dimensional array 50 dimension and character phone number 20 character phone number 20 arrays. Here customer cast 2 only we have put here two customers, customer 1 and customer 2. So integer main problem is the file capital FILE star APTR. APTR is pointer variable. APTR is equal to APOpen p10 customer dot text, and this W this for write mode attribute W is this dot txt file can be created for the output. Integer I print entered the information of customers, storing the information for I equal to 0 I less than 2 plus plus I. Printf enter name, this percentage s for the string customer uh, I for I equal to 0 first customer I equal to 0 dot customer name, and phone number customer I equals to 0 customer 0 first initial customer 0 and customer name and customer 0 dot phone. So input here customer name and customer phone, and I equal to 0 and I equal to 1 second for second customer, this I less than 2. So here we use cast 2. So only two customers, customer 0 and customer 1. So if printf, this is the command for this uh, file open here. This is the file open this if printf if ptr comma double quote start displaying the information this displaying the information for I loop if printf if ptr, because here file star if ptr to open this the we create the file if ptr if open at dot text file. So this is the displaying information. So in the file fptr we store fptr, this is the customer name and customer phone number for two customers, and f close fptr. So we close the function this fptr pointer function and return 0. So compile this and run this. So enter the name, suppose name is this ANIMESH, enter phone number 1 2 3 4 5 6 7 8 9, and this one, and phone number is 98765423, and this. So this is the input, but the output is created in the folder .txt folder, this problem this .txt folder. So we can get the output for this here we fptr this, sorry, APTR store here, APTR, but I cannot find this file. Yes, APTR on this file, customer care.txt. No, in text, in, no, but here today is created but cannot find this file. Customer text. No. Now I am sorry, cannot be open this file. P10 underscore customer text. Next problem. Sorry, with a open displaying open customer text as file1. File content equal to file1 dot read print file content. So run this print file content displaying this. So this is, oh sorry. So only here this open this. So p10 customer dot text as file1. So file1 dot read. So we input get the output the separate file pp10 customer dot text as file1. So we get here the file1, this customer name ONUS and phone number is 1234578 and customer name is Suman and phone number is this. And next file 1 dot closed. So complete this program. This is true. Next problem 11. Write a C program to find the maximum minimum elements of a given array. So here integer A, one dimensional array 1000, I, n, minimum, mean, max, the integer variable, and enter the size of the array, number of array is n. So maybe 10, maybe 20. Enter the integer elements for the array. So integer element 1, element 2, element 3, element 4, up to element 10, and the integer capacity is 100. So A0, A1, A2 up to A90, 999. Mean equals to max equals to A0, initial value this. So if, for loop, if minimum is greater than AI, so first I equal to 1. So when minimum is greater than A1, minimum is A0. So minimum is greater than 1. So minimum is A1. And if maximum is less than A1 for I equal to 1, so maximum is A1. Next, for I equal to 2, I plus plus. So now minimum is A1 and this A2. So A1 is greater than A2. So minimum is A2. And maximum, that means maximum is A1. A1 is less than A2. So maximum is A2. So in this way, we get the maximum value stored in the max variable and the minimum value stored in the in variable. Run and compile this problem. We put here integer value, size of the array, so suppose 5. We put here 5 numbers. So first element 1, say 10. Next minus 40. Element 3, 77. Next 59. minus 99. So here minimum of this array is minus 99 and maximum of the array is 77. Next, problem 12, write a C program to sort the elements of an array in ascending and descending order. So this is the enter the number of elements in array, scan the number of elements in, enter the elements, element 1, element 2, element 3, and element so on 5 or element 10. And for this, number I is greater than number j. First I equal to 0, then j equals to I plus 1, j less than n, plus j. So first I equal to 0, then j equal to 0 plus 1. That is, j runs from 1 up to j runs from n minus 1. So j runs from 1 to n minus 1. So first I equal to 0. So number 0 is greater than number 1. Then a equal to number e equal to number 0, and number 0 equals to number 1. Number 1 equals to a. Number j equals to a. Here number 0 is the I equal to 0 initial value and j equals to 1. So number 0 is greater and number 1 is lower than this number 0. So a equal to this store greater value, and number 0 equals to number 1, and number 1 equals to a. Number of ones to a. The number of ascending order. So by this loop for loop, we ascending order this. So number I equal to 0, ascending order um, from um, from minimum to maximum, increasing order, and descending order means this is the maximum to minimum. So descending or decreasing order. So in number 0 is greater and number 1 is then number 1 is greater and number 1 number up to n minus 1. So compile this problem and run this problem. We put here the enter the number of elements. Suppose enter number 5 elements. So here number is integer type element, so put here integer type element. So 88 minus 99, 45, 77, this 1, 4, number 5. So the number in ascending order, so increasing order is lowest and the 80 is highest. In the descending order, 80 is the maximum and minus 90 is the minimum. So but be careful that when this I plus plus, you must put here I less than n. Here I minus minus, because I equal to I minus 1, you must put here I greater than equal to 0. If you put here I less than equal to 0, then you cannot get for this as a descending order. Next problem 13. Write a C program to read in an array of name and to sort them in alphabetical order. So this problem is also including string header file. So include string.h, and here character, the string character 100 and s equals to the string character, this two-dimensional array 100 and s is one-dimensional array 100. Enter the number of names scanf in printf. Enter the names. Printf name is scanf the string percentage s string 1 string 2 up to string 0 to up to string n minus 1. This name is this. So for loop I equal to 0 to n minus 1, j equals to I plus 1 to n minus 1, and string compare, string CMP, string J, comma, string J is greater than 0. So string copy s comma string copy string I comma string j, string copy string j comma s. Printf the sorted order of names this. Print this. Actually, this is also maybe out of syllabus because this string function and this string copy, string compare actually is you can read for the string copy and this website in this link and this string copy and string compare and we get from this. So this is the difficult problem for the stage semester 1. So here we is enter three names. Name 1 is Nonikor, name 2 and name 3. This actually run this problem, compile this, sorry, terminate file directory fatal error. First we compile first stop this, compile this, run, compile and run this, enter number of names, suppose two names. Name 1, say ANIMESH. Name 2, say Sujit. So two names and the sorted order of the names are ANI, A first and S is second. Suppose here and name is enter name three names say Jupoti, first name, second name Uttam, third name Ovi Rup. In sorted order, first Ovirup, Uttam and Jupati. Because A is first, U and last is Jupati, Z. So this is the order is this order. Next problem 14, write a C program for addition of two matrices. So it is very easy program. Matrix A, matrix B, 10 by 10 size, B is 10 by 10 size and summation is 10 by 10 size and ij. First we scan the matrix A and then we scan the matrix second matrix, then add these two matrix for I loop and J loop, I for row, J for column, and print the first matrix, print the second matrix and print the result. So if we input this we here input number of rows 2 and number of column is 3 and so we get enter the elements a1 1 and this is this way and we get the first matrix is this, second matrix is this and output is the sum of the two matrices is this. Problem 15, let us see program to find the transpose of a given matrix. We also use problem integer a matrix two-dimensional array 10 10, transpose is the two-dimensional array 10 10, R and C row and column integer variable, and first we enter the matrix element and then the print the matrix and compute the transpose by this loop, for loop integer and for integer I equal to 0 to less than r minus 1 and j equal to 0 to c minus 1 because less than c, and transpose gi equals to aij and printing the transpose and we here 2 by 3 matrix, so number of rows 2, columns is 3 and so put here 1 1 a2 2 a1 3 a2 1 a2 2 a2 3 elements. So matrix A is this 2 by 3 matrix and transpose of the matrix A is this 3 by 2 matrix. Next problem 16. Write a program to find the product of two matrices. So here we put here integer I, j, r1, r2, c1, c2. So for first matrix, number of rows and number of columns c1. For second matrix, number of r2 and column c2. Enter the r1, c1 to c2 and matrix A R1 C1, matrix B R2 C2. Enter the first matrix in this way. Row wise input I equal to for I equal to 0 to I equal to R minus 1 minus 1, J equal to 0 to J equal to C1 minus 1. The input here matrix A elements, row wise elements, and enter the second matrix B, input these elements, and printing the first matrix, printing the second matrix, and next multiply by this command, this for loop for j I loop, next for j loop, and nested loop. This j loop is nested loop for this I loop, and AB matrix, product matrix, ij equals to initial value, and multiplication by this new variable k for AB ij equals to ABij plus AIK star BKJ, and print the multiplied matrix AB matrix, print this. Here note that C1 not equal to R2. The C1 is the number of columns of the first matrix and R2 is the number of rows of the second matrix. If C1 not equal to R2, then matrices cannot be multiplied. So you must remember C1 must be equal to R2. So here first matrix 2 by 3 and second matrix order 3 by 2. So first matrix A, we put A1, 1, A1, 2, 1, 3, 2, 1, 2, 2, 2, 3 in this type of elements, and second matrix for B, we entered this type of elements, and the first matrix is this A matrix, second matrix is this, and 2, this is the 2 by 3 is 3 by 2, so multiplied matrix is 2 by 2 matrix, so multiplied matrix AB equal to this. Problem 17. Write a C program to check whether the given strings are anagram. What is anagram? The two strings are anagram of each other if we can rearrange characters of one string to form another string. All the characters of one string must be present in another string and should appear same number of time in other string. Strings can be contain any ASCII character. Example, the rescued and secure. These R, E, E, S, S, C, C, U, U, E, E, D, D. So resign and singer, stone and tones, pierce and spear, 11 plus 2 and 12 plus 1 are all anagram. This. So we check this integer check anagram, character star pointer variable star string 1 character star string 2 character string 1 100 character 100 character string and character 2 100 character. Printf input string 1 size of string 1 and stdin, and this input the second string and string 2 size of string 2 and stdin. If the check anagram, this is the check anagram function. This check anagram function is this integer check anagram, and this. So this is the actually this is the very tough problem for the first semester. Actually, this compare string compare pointer variable, and this is this first program written one. You can put this initial stage first. So you can put here first we write this function to check whether the two string are anagram or not. This is the function for check anagram, and the main function is this. Main program is this. So we put this compile resign singer resign and singer are anagram. So compile this program. This next problem, Armstrong number. Armstrong number actually 153 is Armstrong number because 153 is three digits. So 1 cube plus 5 cube plus 3 cube equals to 153. So this is the number. Since sum of cubes of each digits equals to the number itself, then 153 is Armstrong number. For 4 digits, 1634, 1634. So 1 to the power 4 plus 6 to the power 4 plus 3 to the power 4 plus 4 to the power 4 equals to 1634. So 106,034 is an Armstrong number. So here include math.header file function. We find the number of digits in that number. So either 3 digits or 4 digits. So first we find the number of digits. So order function order this while n equal to n plus 1, x equals to x by 10, and return n. So by this program we can find return n. By this n we can find for this integer x, suppose x equals to 153, then n equal to 3, because x 153 by this the n 1, in first n equal to 0, then n equal to 1, next this the quotient x by 10, so this 153 divided by 10, so 15, and then repeat while loop this n equal to 1 to 3, while x not equal to 0, then loop continued. Function for checking the Armstrong number. Integer each Armstrong integer x. Order x, call the order. First we find the number of digits, and this temporary variable equals to x. So we stored the number in temporary variable. Sum equal to 0. While temporary variable is not equal to 0, then integer r equal to temporary modulo division 10 to get the remainder. Sum equals to sum plus r to the power n, and temporary equal to temporary division 10 because we get the quotient. So if satisfies the Armstrong condition, uh, that is if sum equals to s. So this power to the power the number of digits. These are 153. So 1 to r is 1, n is 3. And next plus 1 5 to the power 3 and 3 to the power 3. So sum equals to n, return 1, else return 0. So when sum equals to s, that means return 1, then we say this is a x is an Armstrong number. So integer x input, x can scan. If each Armstrong x equals to 1, yes, it is Armstrong number. Otherwise, it is not Armstrong number. Enter the number 153. Yes, 153 is an Armstrong number. Suppose 236 is not an Armstrong number. Next, 18b, write a C program to check a perfect number. What is perfect number? Perfect number is a positive number which sum of all positive divisors excluding that number is equal to that number. So 6 number of divisors, 6 is 3, and there are 1, 2, 3. So sum of divisors equal to 1 plus 2 plus 3 equals to the number itself 6. Then 6 is a perfect number. So this is the program: integer in, I sum, integer min, integer mx. Input the number, sum equals to itself 0. The positive divisors I, if in modulo division I equals to 0. Actually, this means that n is I divisors. We by this we find the divisors of this. Print d. The sum of the divisors equals to sum equals to sum plus I. Actually, sum initial value sum is 0, and the divisors, if I equals in modulo division I equals to 0, remainder is 0, then I is a divisor of n. So sum divisors, this is the sum equals to sum plus I, the sum of divisors. So if sum equals to n, then it is a perfect number. Otherwise, it is not a perfect number. So here we put here print the divisors. The positive divisors are print this I, print this I to check the divisors. So here we input here 28, and the divisors, positive divisors are 1, 2, 4, 7, and 14. So sum of the divisors is 28. So it is a perfect number. Problem number 19. Write a C program to check whether a number is a prime number or not. It is a very popular program. So here in I flag equal to 0, integer, change flag to 1 for non-prime and 0 for prime. So here n equals to 0 or logical or n equals to 1, then flag go equal to 1, because 1 and 0 are non-prime numbers. 1 is trivial prime. Then flag equal to 1. So the flag equal to 1 means non-prime. And then from I equal to 2 and up to I less than equal to n by 2. n by 2. n by 2. So if n is divisible by I, then n is not prime. Change flag 1 for non-prime number. In modulo division I equals to 0, then n is divisible by I, then flag equal to 1 and break. If flag equals to 0, print this is prime number. Else print positive divisors of this number are these positive divisors are this. So this is not prime number. So run this problem, compile and run this problem. Enter 124. So this the positive divisors are these. So obviously it is a non-prime. It is not a prime. Next, again compile this. Suppose this is the one is 97. 97 is a prime number. There is no divisors. Problem 20. Write a C program uh, for summing a series 1 by 1 factorial plus 2 by 2 factorial, 3 by 3 factorial, and so on, n by n factorial. So first we factorial by recursion factorial n. This is the function for factorial function. This unsigned long factorial type integer main put sum. This sum equals to 0. In series, this sum equals to sum plus float I. This means I is integer variable, but by this right float, so I convert to float variable, and the float factorial I, because the division is this. This is the uh, float type division, not integer type division here, because if I and factorial I integer type division, then there is truncated error, decimal points truncated. So we first convert this float type, both float type. In this print sum equals to the series sum. Enter the value of n5. So series is 1 by 1 factorial, 2 by 2 factorial, 3 by 3 factorial, 4 by 4 factorial, 5 by 5 factorial, and sum is this 2.708333. Problem 21. C program to compute approximate value of pi. Here we use Nilkanto series, and by this series pi equals to 3 plus 4 by 2 star 3 star 4 minus 4 by 4 star 5 star 6 plus 4 by 6 star 7 star 8 and so on. Here for this series we calculate up to uh, 1 lakh, 10 lakhs, 10 lakhs. You can find, you can use 1 lakh also, 1 lakh terms for this series. Pi equal to pi sign means this positive or negative. So when sign equals to initial value sign is sign into -1, first here call this function sign equal to 1. Here the main function sign equal to 1, and after multiply sign 1 into -1, then convert this sign -1. This is 4. First initial term is 3. So first pi equal to initial value equal to 3. And then pi equal to call pi, cal pi, calculation of pi. Cal pi is the function, double pi, double n, double sign. This I equal to 0 to I equal to 1 lakh terms, and I plus plus 4 by n star n plus 1 star n plus 2. So this in here n is this n equal to 2, initial value n equal to 2. So first 2 into 3 into 4. So we get the first term 4 by 2 into 3 into 4. And after increment I equal to I plus 1. So I equal to I plus 1, n equal to n plus 2. So first n equal to 2, then n plus 2, n 4. So then we get 4 by 4 plus 4 into 5 into 6. So this, and this function pi equal to this pi plus this. So uh, up to 1 lakh terms added. compile and then run this approximate value of this 3.1415 and so on, so on, so on. Actually, this is the 0.2020 decimal places here. Calculate a point 0.20 LF. This is the double for double notation, a percentage LF for double formatting. Problem 22, compute the area under a given curve. Actually, we use here the trapezoidal rule for numerical integration. And so first we define the function integration fx dx. So here fx is y equal to fx. First we define into as double f is argument double x. Return the value. Suppose this function is 1 by 1 plus x square. This is the function fx. So we integrate this 1 by 1 plus x square integration 0 to 1. Alternatively, you can define this fx as hashtag define fx space 1 by bracket 1 plus power x comma 2. This enter the subintervals. Suppose subintervals is 6 or 10, or this enter the initial value a, suppose a equal to 0, and final value b, limit, lower limit and upper limit, final limit, upper limit. Actually, initial limit means the lower limit. Actually, this is the lower limit. So 0 and upper limit is 1, maybe 2, 3, and being trapezoidal rule, a is the step length. This is the absolute value of b minus a. This because b and a are this, float type variable. So here we use f abs, ab minus a by n, and for I equal to 1 to I less than n, I plus plus, x equals to a plus ih. Sum equals to sum plus fx. Integral is the formula, trapezoidal formula, h by 2 into fa plus fb plus 2 into sum. Sum means this f x1 plus fx2 plus fx3 and so on. This is the sum, total sum, and multiplied by 2. This is the trapezoidal formula, and print the integral of this up to 10 decimal places. This is the subintervals. You use your 20 subintervals. Initial value, initial limit. So run this problem. Here 0.785 lower limit and upper limit. Subintervals, suppose subinterval is 10 and the lower limit is 0, upper limit is 1, so 0.784, almost same when we use subinterval 20. Next, problem 23, solve a quadratic equation ax square plus bx plus c equal to 0, where a not equal to 0 and a, b, c are all real numbers. So it is also a popular program. This is double variable ABC, discriminant root 1, root 2, real part, imaginary part. Discriminant b square minus 4ac, discriminant greater than 0. There are two distinct roots, root 1 and root 2. And discriminant equals to 0, then two roots are equal. And if discriminant is negative, else, then real part is this and imaginary part is this. So here we get if a equal to 5.82, b equal to minus 9.26, c equal to 7.15, root 1 is this complex root and root 2 is this another complex root, conjugate complex. Problem 24, write a C program to solve the system of linear equation a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 equal to 0. So for this simultaneous linear equation, a1, b1, c1, a2, b2, c2, and x and y. And enter the coefficient a1, b1, c1, enter the coefficient a2, b2, c2. And if a1 by a2 not equal to b1 by b2, because this for unique solution, a1, b1, so actually this represents a straight line. When a1 by a2 not equal to b1 by b2, That means there are intersecting straight lines, and so we get unique solution intersecting straight lines. So, and x equals to this is the cross multiplication rule. We use here cross multiplication rule. So x equals to this and y equal to this, and print the value of x and print the value of y. And for infinitely many solutions, if a1 by a2 equals to b1 by b2 and b1 by b2 equals to c1 by c2, then the coincident straight lines here. So coincident straight lines means there are infinitely many solutions. So given equation represent coincident straight lines if this condition holds a1 by a2, b1 by b2 equal to c1 by c2. Then we can write this solution by this way: y equals to this some function plus sum into x. So x is arbitrary. So this y equal to minus c1 by b1 and plus minus e1 by b1 into x. For no solution, parallel straight lines, that means a1 by a2 equals to b1 by b2 and logical and b1 by b2 not equal to c1 by c2. Then parallel straight lines, actually if the constant c1, c2, 0, then this straight lines passing through origin. This c1 not equal to c1 by c2. So we get b1 by b2, sorry, b1 by b2. So this b1 by b2 not equal to c1 by c2. Then we get parallel straight lines. So no solution, actually parallel straight line, no solution here. So here we enter this coefficient 1, 2, 3 and 2, 4, 6. Here note that 1 by 2, 2 by 4, a1 by a2 equal to b1 by b2. So no solutions is possible here because the third case and not equal to c1 by c2, 3 by 5. So hence no solution is possible here. Compile this problem and on this problem we first enter this a1, b1, c1. Suppose put here 2, 5, 8. Here a1, b1 are all of double type, so you can put uh, decimal point. So minus 9.2, 7.5, 2.6. Here the equation represents intersecting straight lines, hence the solution is unique and value of x is this and value of y is this. Next problem 25. Write a cyclogram to find the shortest distance between two straight lines parallel or intersecting or skewed. Actually, we use the term shortest distance for skewed lines. So intersecting straight line distance is 0 and parallel straight lines is the perpendicular distance between these two lines. So we use skew lines, we use shortest distance term actually for skew lines. So there are three cases for two lines intersect each other at some point. If we write these two equations, two straight lines, r vector equal to p vector plus t into a vector, t is the scalar, a vector, and r vector, another vector is r vector equal to q vector plus s into b vector. Here t and s are scalar. Or this first straight line can be represented as symmetrical form: x minus p0 by a0 equal to y minus p1 by a1, z minus p2 by a2. Here p is the vector with components p0, p1, p2, and a is the vector with components a0, a1, and a2. This is the symmetrical form for the straight line. Or r equal to q plus sb. So this straight line passing through the point P with position vector P and parallel to the vector A, and second straight line passing through the point Q with position vector Q vector and the parallel to the line B. So for the first case, intersect each other. Then for some t and s, for particular some t and s scalar, we get p plus t into a equals to q plus s into b. For particular values of the scalar t and s, we get for unique solution for t and s. Then we can say these two straight lines are intersecting. But it is very difficult program to test this whether these two straight lines intersect each other. So here we avoid this case. And second case, parallel to each other, then this p equal to r p sorry r vector equal to p vector plus t into a vector, and r vector equal to q vector plus s into a vector. So here either this a vector or scalar multiplication of this a vector are same. So then we say these two straight lines are parallel straight line, and then the distance between these straight lines is this formula q vector minus p vector cross product a vector whole modulus of this divided by modulus of a vector. Intersecting straight lines and parallel straight lines lie in the same plane, that is are coplanar. So intersected straight line distance is 0, but parallel straight line distance is this. But both they are coplanar. Third case, they can be neither intersecting or nor parallel to each other, also known as the skew lines. And two skew lines in vector form is this. Here short distance is d equals to q minus p dot a cross b whole modulus divided by modulus of a cross b. First, here the function shortest distance function double p3, q3, a3 and double b3. So first we here cross product a cross b by this modulus c, that is the modulus of a cross b, and this, and difference q minus p is this because we compute this formula q minus p a cross b by mod of a cross b. So mod of a cross b is this. Q minus p is called q underscore p, is three-dimensional array. So q0 minus p0, q1 minus p1, q2 minus p2. And if this a0 by b0 equals to a1 by b1, and logical and a1 by b1 equal to a2 by b2, and a2 by b2 equal to a0 by b0, then the condition is parallelism. Two straight lines are parallel. And if q0 equal to p0, that is q0 minus p0 equals to 0, q1 minus p1 equals to 0, q2 minus p2 equals to 0, that is the coincident, because parallel and intersecting this point p and q. So these are coincident straight lines, and distance is obviously 0. Coincident straight lines, so obviously distance is 0. When parallel, else this parallel straight line, that means a cross b equals to 0, but not coincident straight lines. So distance is q minus p cross a modulus by modulus of a. So first we find the modulus of a, mod underscore a, the square root of a0 square plus a1 square plus a2 square, and the double variable q underscore p x a3. This means q minus p cross a. Q minus p, already we find q minus p is this vector, and this a vector is a0, a1, a2, a3. So q minus p cross a vector. So we put here three components: this component, first component, second component, and third component. And d vector is the actually d vector is the square root of this this square q, this q underscore p x a square 0 square, and this square root of this square component, three component, first component is square, second component is square, plus third component is square. D vector square root of this actually is the modulus of this. So we can find this parallelism. This is the modulus of this, modulus of q minus p cross a. So d vector is the modulus of q minus p cross a, and this divided by modulus of a, is the d is the distance of this. And else, that's for skewed lines, unit vector n is the a cross b by modulus of a cross b. So this n is the unit vector this C0 by modulus of C, C1 by modulus of C, C2 by modulus of C. Because modulus of C means the modulus of A cross B, and C vector is A cross B vector. So already we defined C equal to A cross B vector. So this, and dot product, it means the Q minus P dot A cross B by modulus of A cross B. So dot product is this Q minus P dot, this is the unit vector n is this A cross B by mod of A cross B. So dot product of this. So with the magnitude modulus of dot product is this absolute value of dot 0, this dot product is this dot of this component of this square dot 0 plus dot 1 plus dot 2, because short distance is the SD equals to SD. Dot is this absolute value of this dot SD is equal to absolute value of this dot of this eta, this dot is this eta dot eta component of this. So actually add this component abs modulus of this. Two skew lines in this, actually dot here Q minus P dot this B dot B A1 A2 plus B1 B2 plus C1 C2 A1 A2 plus B1 B2 plus C1 C2. Actually this dot product eta into eta plus eta into eta plus eta into eta. Actually component, we get component, and modulus of this means dot of this. So actually we add this component this plus this plus this plus this. So dot product is this. So we put this scalar, this cancel this dot eta plus eta plus eta. So 8 abs of this 8 abs 8 abs of this. So dot is this is modulus of. So dot equals to this. So actually this d is d equals to actually this is d equals to this. So put this is d. the so this SD equals to f(f)s of this. So enter the three components P, components of Q, components of A, components of B, and find the short distance PQAB. This is called the function short distance PQAB. So because short distance is this, is equals to this. So enter the values of P. Suppose 2, 1, and 5. Component of P, component of Q, second line passing through the point Q, say -1, 5, 7. Component of A is 2, 2, 8. 8, say 9, 7, 3. And the required short distance is 4.897613 unit. Actually, dot means the scalar quantity. So f(f)s means the modulus value of this. So it is correct. Last problem 26. Write a C program to prepare the investment report by calculating compound interest. So here compound interest, the formula is the amount equals to principal value into star 1 plus r by 100 into n whole to the power n star t. So this is the p star this whole to the power this, or of this and this, or function this comma this, and cumulative interest, sorry, compound interest, CI means compound interest, amount minus the principal value. Here P is the principal amount, R is the interest rate annually, and T is the time period. If compounded yearly, then n equal to put here in 1. If monthly, then put n equal to 12, and so on. Quarterly, n equal to 4, and bi-monthly, n equal to 6, and so on. This is the function compound interest, integer n, double p, double r, double t. Double A is the amount equal to the p star power 1 plus r by 100 into n, comma, t star n. Return a minus p for compound interest. Here double PRT. If compounded yearly n equal to 1, half yearly n equal to 2, quarterly n equal to 4, monthly n equal to 12. First, bank A. Bank A here compounded half yearly. First bank A compounded half yearly, and principal value is 10,000, rate of interest 7, and time for 5 years. So we call compound interest for A bank CI underscore A, compound interest 2, 10,000, 7, 5. 2 for first two for this function integer n 2 for this 2 for half yearly. So this compounded half yearly, so put here n equal to 2, and this p for principal value, this r for rate of interest, and this 5 is the years. This compound interest for bank A, this, and compute the compound interest for bank B, and this the bank B compounded quarterly. Here, so n equals to 4, principal value 10,000, rate of interest 7, same, and for 5 years same. Only difference is they are compounded half yearly and compounded quarterly. So compound interest, calculate this and report if CI underscore A is greater than CIB, bank A is better than bank B, CIA is less than CIB, bank B is better than bank A, and else bank A and B are same. Here, Bank A compounded half yearly. The compound interest for Bank A is 4,105 and so on, point something. And Bank B is this. So obviously, Bank B is better than Bank A. Thank you. We complete our lecture.